Oh man, I've got ourselves. We got an absolute doozy here. Okay, we got circle D. We have the measure of angle A is x squared minus 3x. And I know what you're thinking. You're like, bro, you're throwing a quadratic at me. Heck yeah, I'm throwing one because we can handle it. Okay, and then I've got the measure of angle ABC is 10x plus 18, and I want to solve for x. Well, let's go ahead and start labeling. I've got angle A is x squared minus 3x. All right, and I've got angle ABC. I'll do this one in pink here. Is 10x plus 18. Okay. Lovely. I also happen to have two congruent arcs here, and that's very interesting. So my blue angle, the x squared minus 3x, intercepts just that arc right there from B all the way to E. And then our angle ABC intercepts this whole arc, right? AEB. So what can we do with that information? Well, the blue arc is intercepting half the amount. The blue angle is intercepting half the amount of arcage, if you will, as the pink angle is, right? So would it make sense that I could just set x squared minus 3x equal to half of the other one, right? Because it's intercepting half the amount, so its measure should be half the amount, right? So if, say, for fun, the pink arc was, how about 200 degrees, okay? Well, that would make each half here 100 and 100, right? So that would mean that the pink angle is 100 degrees, right? Because it's an on angle. It's half of its intercepted arc, the 200. And the blue one is half of that 100 degrees that's left over, so that it's 50. So the angle A there would be equal to half of angle ABC, and that's what we have set up right here. Okay, those are fictitious numbers, just to prove a point there. So we have a workable equation here. Let me get rid of those. Those aren't real values here. We actually need to solve them. Okay, and it works out really well here because I could either multiply by 2 on both sides, or since we have even numbers we're dealing with on the right-hand side, I can just go right to x squared minus 3x equals 5x plus 9. I can just divide both of those by 2. Now, since I have a quadratic, I'm going to set equal to 0. I'm going to get x squared minus 8x minus 9 equals 0. And I can factor what multiplies to negative 9 and adds to negative 8. That'd be negative 9 and positive 1. And now I can go ahead and solve and get x equals 9 and x equals negative 1. Now the question here is, do they both work? Does one of them work? Do none of them work? Is there no solution here? If I plugged in 9 to this one here, I'd get 81 minus 27. That's a positive number. If I plug it in here, I'll get 90 plus 18. That's a positive number. If I plug in negative 1, I'm going to get 1 plus 3, which is a positive number. And over here, I'm going to get negative 10 plus 18, which is a positive number. That last one, really easy to compute, actually. It's going to be 4, and it's going to be 8. Obviously, it doesn't look like it would actually work in the context of the problem, right? But we do have positive answers here for this one, okay? We do have positive angle measures. And I do want to address that whole idea of like the 9, it works, right? We know that for sure, right? I get 81 minus 27. That's going to be 54. And I'm going to have 90 plus 18. That's 108. Okay. So those definitely make sense in the context of this problem. The reason why I say that is AB right here. AB is on the other side of that center of that circle, right? And so angle ABC is intercepting an arc that's definitely more than a semicircle, okay? So this would have to be an obtuse angle. 108 is an obtuse angle. So that works, right? And then 54 is half of that, which is what we were expecting here in this equation. When I plug in negative 1, however, I end up getting 4, and then I end up getting 8. Well, can that angle actually be 8 degrees if it's intercepting a major arc, an arc that's greater than 180 degrees? No. So technically speaking, that would also be an extraneous solution, but very much in disguise there. Not something that we would necessarily count off, at least in our class. More of a challenge problem there of which one of these two solutions is not working in the context of the problem and why. That is hard to tell, okay? So 9 works based on the diagram and where the placement of chord AB is with respect to the center, right, and having an obtuse angle. Definitely a tough one to read there. Overall, solid problem. I liked it. That was awesome. I hope you guys liked it too. So have a wonderful day, and enjoy some sunshine because it's shining right now. But it depends on what day you're watching this. See you later.